Dear students, this is Dr. N. Venkatachalapathi, Institute of Aeronautical Engineering. I am going to discuss on some of the problems related to metalworking process. So, especially the manufacturing process deals with not only theoretical subject, it is having some of the basic fundamental concepts which is related to some simple formulas also will be there in order to determine some clearances and forces and some of the what you call some drawing forces, some of the blank diameter, all these parameter can be determined easily. But especially some textbooks in P.N. Rao, only a few formulas will be given. But in general, some metal casting by Rosenthal textbook and some of textbooks from Goshen Malik, the variety of problems also will be there. And in this session, I'm going to give the clear idea of the how the metal working or mechanical working of metals topic. The deep drawing in the sense making the mixie jars and cups and all, how to determine some simple concept related to some problems. Okay, so this type of topic, so many times they asked every couple of years, one 2 marks and 5 marks question will be there for gate problems. And with this concept, any student can easily follow and solve this type of problems. Okay, now let us see the before going to give our presentation. First, let us recap of the what is drawing. So what are the types of drawing process, and which is the important concept of this drawing. And this drawing already I explained in the previous slides also, but in this session mainly focus on the solving some of the simple problems and some of the formulas which is related to this drawing. Okay, now look at especially the term drawing can be defined as it is a metalworking or mechanical working of metals, and also it is a cold forming process. It is a cold forming process. From this diagram you can clearly understand. So there will be a die. So there will be a die, and above that some what you call punch. Okay, and in center there will be a punch or punch force, and the straight sheet some bend, that is called blank or strip, whatever you can call it as a blank or strip, depending upon the applying of the compressive force only it can able to bend, and how much force is required you can able to bend properly. That distance can able to form certain cup shape, and some triangular shape and helical shape can be obtained. And in this drawing operation you can able to keep some of the blank holders in order to support that strip cannot move up and down, and there is no some vibrational changes can be occur, so that the blank holder can be kept above the guide plate. So even the guide plate also very important to strengthen this strip or workpiece, so that that uniformity can be obtained. Okay, so now look at how we can able to have some cup shape. So especially in any drawing process, this comes under the some deep drawing process. Most probably some cup shape components. Some cup shape, and what you call some mixie jars, all this comes under this deep drawing process or deep drawing technique. It is a cold working process. Here, no need to heat the metal. No need to heat the metal. Only thing is, a drawing is a process, cold forming or cold working process, that directly the cold sheet, a workpiece or strip can be kept above the die, and there you can support of some blank holders and guide plate can be used. So that whatever the shape of the halo, that cup shape can be easily formed. And here, while halo vessel without much wrinkling, wrinkling, trimming, or what you call some fracturing can be happen when sudden force can be applied. Some compressive forces, some winkling means some like that strips can be formed at the end of this die punch forces. That extra parts can be removed by some trimming process. That is why while solving the problems in the that drawing forces, some clearance should be removed. 0.6% or zero point 0.6 clearance can be detected from the drawing force because of this trimming. Some excess flash can come out of that, can be eliminated with easily with the simple cutters also. Okay, so that is why this basic fundamental concept is required to form a some cup shape mixy jars can be made. So in that generally what is the importance of the blank and what is the importance of the punch? Yes or no? And similarly, how you are going to have this, how much punch force is required, so how much blank force is required, and where you can add the clearance, where you can detect that is a very concept behind in this solving the simple problems. So almost the punch making a hollow portion, there you can add, and blank means you can able to subtract. Like that we'll discuss in detail about this session. Okay, so this is about the main concept of the drawing process, and look at how to give some introduction of this drawing process. So in general, this terminology is very very important. Okay, the terminology in the sense, well, cup shape mixy jar can able to perform this deep drawing process. This is also called the deep drawing process. In a deep drawing process, what will happen? You can able to produce some shell. Shell is the, what are the exact shape of the shell? A shell having the thickness, larger diameter, inner diameter, and some radius, inner radius, and punch radius. Smaller is the punch radius, capital with the draw die radius, and here also some small r is the punch radius, where you can use the blank draw die radius. This is capital R with the draw die radius. The punch, where you can use the punch radius. Always draw die radius is greater than that punch radius. Okay, and there will be blank, and how much force is required. Compressive force is required to change that cup shape and shell shape, etc. And this is also called some thickness, strip thickness. Okay, so if it is a straight sheet, this is a strip thickness, and how we can perform the straight to a some rectangle or channel shape, cup shape. Okay, so this is T, and this is what how we can able to bend effectively with this drawing process. Okay, and with this basic fundamental concept, how we can able to determine the drawing force, what are the clearance to be added for the punch or die, that we'll discuss in detail. And these type of problems are very much important for the gate examinations, some competitive examinations also. Look at so I hope every student you know the basic operation in a drawing. So there will be a straight sheet will be there. In the sheet, how you can able to apply force, compressive force in the punch, so that the rectangular or some square shape can be performed with this operation. Just like it is setup should be almost or similar to the blanking operation. Even the drawing is the different. The punch and die are the given necessary rounding at the corners. So look at in this what you call trimming at the corners, sharp corners should be avoided, so that this process can be performed easily. And wherever some extra trimming and some cup shape can be reaches for the portion of the die, the top edge will be the cup form, the punch expand be due to the spring back. Suddenly when you apply compressive force, when you open it, suddenly it come out, that known as spring back technique. Okay, and the limiting thickness is also controlled by gap between the die and blank holder, so that the spring pressure, which in case of spring loaded blank holder. Okay, so that is why here blank holding force is also one important parameter to determine the blank holding force. And here, due to cold working process. Due to some friction and more pressure can be taken. So in order to avoid certain restrictions of the friction, a lubricant is generally used to over the blank to reduce the friction, and hence drawing load can be reduced. Okay, so look at, these are the important formula. So these are the very very important formula to give for the drawing. Okay, so the drawing in the sense deep drawing. So and wide drawing also is there. That wide drawing is different from the deep drawing. Deep drawing means just like cup shaped mixie jars. Best application is mixie jar can be able to produce with this. So there are three different type of formula is there. So one important thing is the small d. So that is outside diameter of the cup, and R is the corner radius of the punch. R is the corner radius of the punch. This is the corner radius. And what about the draw? This is a cup. Draw outside diameter of the cup. Outside diameter of the cup. Okay. So in general, when you wanted to determine diameter of the blank or blank diameter, capital D can be determined very easily, and the blank size can be generally difficult to find exact size of the blank which is needed to drawing to given a cup shape. So exactly if you put one compressive force, it is difficult to form a cup shape. So exactly when you wanted to get 100%, so first initially when the first draw, what will happen? Some exactly some 60% of material can be drawn. The second, say 40 or 30% of reduction takes place, and 20 or 10% can be reduction taking place. Like that, you can able to have that 100% can be obtained. Okay, so 40 or 30, 10 or 20, and 50 or 60. So some cases 40 also will be there. At least minimum 2 to 3 draws, or minimum 3 to 4 draws, or minimum, most probably minimum 2 draws required to any shape. So suddenly one complete shape cannot able to maintain the exact form of that cup. So that is why always you can need to check which type of formula to be used for the that ratio, draw ratio. So that is called D by R ratio. Always D by R ratio which is greater than 20. So D by R ratio will be greater than 20, means almost all we are supposed to use what you call blank size diameter. Capital D is equal to root of small d square plus 4dh minus 0.5 r. Okay. So sorry, this is wrong only. Above 20, so this is not there. Directly, no deduction of this thing. Only blank size is equal to root of d square plus 4dh, where the d by r ratio will be greater than 20. If in between 15 to 20, almost all you can able to deduct 0.5 r. And if it is in between 10 to 15 or almost all, this point 5r root of d square plus 4dh minus 5r to be deducted for in between that ratio, draw ratio. Okay, so the blank size is a very very important parameter in order to determine the total blank diameter for making this. Either it is a one draw or two draw, that percentage of reduction also will be taken. That is percentage of reduction. Percentage of reduction. Percentage of reduction will be takes place 1 minus d by d. So that is capital D minus small d by capital D into 100. So this is the how many draws is required to determine the that cup shape, or mixie jar cup can be also determine this deep drawing process. Okay, so especially while solving the problem, in general they may give the that the small d outside diameter of the cup will be given, h height of the cup will be given, and the corner radius either 5 or 2 that corner radius of the punch also will be given. So with these three, you need to suppose to determine the blank size or blank diameter can be capital D can be easily determined. The capital D can be determined by simple formula root of d square plus 4th, where d by r ratio is greater than 20. So d by r ratio, the outside diameter by that smaller is nothing but corner radius. That ratio will be more than 20 will become obviously without any reduction, root of d square plus 4dh formula to be used for determining the blank diameter or blank size. Okay, suppose when you calculate initially, that is what in the problem they may give the height of the curve, outside diameter of the curve, corner radius of the punch will be given. So first you need to calculate d by r ratio. So for example, d by r ratio, outside diameter is suppose outside diameter is some 60 is there, outside diameter, and corner radius will be given some uh, corner radius will be given some 20, some what you call some corner radius given some 5 okay, suppose corner radius will be given some 2 so that d by r 2 into 30. So 30 means all weight is greater than 20. So d by r ratio is greater than 20 means directly you can use the root of first formula d square by root of d square plus 4d h. This formula is used to check directly blank diameter or blank size. Suppose if the d by r ratio is in between 15 to 20 r, in between 15 to 20 r, so that is almost all what you call, suppose if you take 60 divided by some 8 or some, if you take some 5 60 by 5 5 1, okay, 10 5 2, it is 12 so that is 12 means it is d by r ratio will be what you call 10 to 15, that is almost all minus this formula to be used. Suppose if it is d by r ratio is in between 15 to 20 means we can use the 0.5 or r by 2, small r by 2 formula to be used to determine the blank diameter. So these problems, these type of problems every year they may ask in the gate examination, competitive examination. So they will twist like initially they will give the outside diameter of the cup, height will be given, corner radius will be given. First you should do, before going to determine the blank size, first you can need to have the draw ratio. So in this ratio, the d by r ratio we will calculate. So depending upon that ratio only, you can identify which formula to be used for the determining of the blank size. Okay, so when the d by r ratio will be greater than or equal to 20, obviously the first formula root of d square plus 4dh, this formula to be used. When it is in between 15 to 20, you can use the root of d square plus 4dh minus 0.5r. Suppose if it is in 10 to 15, d square plus 4dh minus 5r. So these are the three formulas are very very important to determine the blank size. And another interesting one, how do you determine the drawing force? Whenever it is a cylindrical shell having the circular cross section, obviously the term maximum drawing force can be determined by a simple formula, that is P is equal to kt dt y or s, whatever you can say that, where here small d is the outside diameter of the cup and t is the thickness of the material, y is the yield strength of the material, k is the constant factor, the factor whose value approximately which is equal to some d by d minus r. So that is why, so that P is equal to, so P is equal to, so it is interesting when you wanted to determine the drawing force, it is a very simple formula to be used. The drawing force P is equal to some thickness d and yield stress, and that constant k is equal to d by d minus 0.6 is the clearance. Okay, so here where T is the thickness of the material, D is the outside diameter of the cup, Y is the yield strength of the material, and D by D ratio, blank size by small d, outside diameter of the cup, minus this 0.6 is the some clearance for the that trimming or excess material come out of that like a flash, that you have to detect. With this formula, you need to determine this drawing force as per the requirement of the uh, formulas. Okay, so this is what about the drawing force can be easily determined by this. So these are the important formulas to solve the any type of problem. So majority of the student, they feel that it is a purely theory exam, nobody will ask some problematic topics also. So only competitive examination, even some recently in IES and some uh, central government examinations also, they'll ask what is the blank size if they given outside diameter of the cup and corner radius and height of the cup, how do you determine like that? First you need to calculate the d by r ratio. Based on the d by r ratio only, the which formula to be used for determining the blank size can be obtained, and force also can be determined, that t dy, so thickness of the material, diameter, outside diameter of the cup, and y is the yield strength. In that case, the constant factor whose that is equal to d by d minus zero point 0.6. And here, this is also another interesting and important formula in blanking and piercing, especially the clearance, where you have to provide clearance for a if it is a blanking operation, always you can able to deduct the clearance in a blank. Okay, and when it is a piercing operation, you can add the clearance. So this is what very interesting one. So for example, punched out part. So this punched out part, this is called blank. That punched out part, always the blank size, which is nothing but die size. Whatever the die size is equal to the same blank size. And when you wanted to determine blank punch size, that is making a hollow portion. So this is a hollow portion. That punch size, which is equal to blank size minus 2 times of clearance. Okay, so because for example, if it is a radius means 2 times of RR, that is 2R. That R is the clearance, like that. Okay, so almost all punch size when you wanted to take for the blanking operation, you should exact the die size, you deduct the 2 times of the clearance or 2 times of that inner radiance can be deducted. Okay, and if it is a piercing operation, the piercing operation is nothing but what you call the piercing operation is nothing but making the hollow portion. So how you can able to prepare this hollow portion? Making a hollow portion where the here is punch size is equal to blank size. Punch size is always equal to blank size. Then or how to determine the die size? Die size is always equal to blank size plus 2 into clearance. So this is very interesting. In a blanking operation, so in a blanking operation, always to determine the punch size, we can deduct the clearance. In a piercing operation, Die size means you can add the clearance. Yes or no? You can add the clearance so that the punch is make hollow portion can be easily done. So in this you can clearly can see the blank size is nothing but blank size punch size plus 2 clearance. Okay, so here punch size is nothing but blank size, where the piercing operation is equal to blank size is equal to the die size minus 2 clearance. Okay, or that die size is nothing but what about this punch making a hollow portion, making the holes. And finally, the clearance is nothing but kt tau. So k is the constant factor, that is almost 0.003. 0.003 into what you called t is the thickness of the material, tau is the shear strength. Shear strength, when you determine easily the clearance, or sometimes we'll call the this force for punching force and blanking force can be easily determined. So this is what about the some important formulas to solve these some of the competitive examinations like GATE, IAS and other central and state government examinations. Okay, so this is what about the main important conclusion of this process is in a drawing operation, only speaking cup shaped and all, it is a deep drawing process. So where deep drawing, the terminology is very important. Punch radius smaller, draw radius capital R, and almost of the shell, rectangular shape shell, that size is thickness, and how do you determine that guide plate, and how we can able to determine this cup shaped particles using uh, that pressure and force. That drawing force can be determined by, so that thickness, diameter, and stress, shear stress into some d by d minus some constant factor. Okay, that constant factor will be zero point 0.6 can be deducted for trimming and some extra material come out. And similarly, when you see this is what about how we can able to determine the blank size or blank diameter capital D. Capital D can be easily determined by a simple formula which is called the root of d square plus 4dh. Root of d square plus 4dh. That small d is nothing but outside diameter of the cup. So if it is a cup means this is outside diameter of the cup, and this is the height. H is the height, and so small r is the corner radius of the punch inside. This is the corner radius of the punch. Corner radius of the punch. So whenever the d by r ratio will be greater than or equal to 20, if it is d by r ratio is greater than or equal to 20, you can use this formula. Suppose d by r ratio in between 15 to 20. 15 to 20, you can go for the minus 0.5 r. If it is 15 to 10 to 15, 10 to 15, d by r ratio is nothing but minus 5r. So these are the three important formula to determine the blank size or capital D. Okay, almost the percentage reduction is the one of the major factor. One single draw, exactly some 40% can able to reduction takes place in the first draw. The second draw, second 30% or 20%. Third draw only 10% or 20% can be reduction takes place. So that minimum 3 draws is required to determine that cup shape particles. And here also the drawing force can be determined with a simple formula, some k, t, d, y. So almost all t is the thickness of the material, where d is the outside diameter of the cup, y is the yield strength of the material. So that yield strength is where you can use the some non-ferrous metal or some copper, what are the metal to be used, that material yield strength to be considered. And zero point 0.6 is the some extra material, some trimming and some wrinkling will be occur, that elimination we have to deduct that 0.6 only. Okay, so these are the some standard design values where you wanted to design this component, we can able to use. Okay, so this is what about how do you solve the simple problems by using this deep drawing technique and this clearance, die size and punch size. And what about the blanking operation? Almost you can detect the clearance in the punch size, but whereas in the piercing operation you can add the clearance in the blank size to determine the punch. Okay, so almost all the term blanking can be defined as the punched out part. So here this will be the workpiece, this is a scrap. Punched out part is the workpiece, the hollow portion is the scrap. Where in the case of piercing means this is the workpiece, the hollow portion is the workpiece, and the remaining come out, this is the scrap. Okay, so that is why almost all in a piercing operation, the punch which is equal to the blank size, when you wanted to determine the die size means you can add the clearance. So that is the only difference you have to remember. So they will confuse in the gate examinations, but where you can apply the clearance, where you can detect the almost all piercing operation only can add the clearance. For blanking operation, you have to detect the clearance. This is the only concept to be remembered. I hope all the students understand this simple deep drawing and blanking piercing technique to solve the simple problems. Any type of problem you can do it, select it is available in the any other textbook like P. and Rao and Ghosh Malik textbook. You can solve it, and if you are not get any, you can bring to my notice and to solve the any complicated problems. Okay, so thank you very much for this session.
Like, share, and subscribe. Hit the bell icon for more updates.